Welcome to this demo of Database Impact Advisor. Database Impact Advisor is a feature in the Exadata Management Pack. Database Impact Advisor integrates with AHF Balance to perform system-wide Exadata CPU usage analysis to identify databases impacted by noisy neighbor issues. In a cluster where you have several databases, then it is possible for every database to use as much CPU as it can. But it's also possible to restrict individual databases from using all the CPUs. This is done by setting the CPU count init.aura parameter. Default is 0, which is no limit. Except from that, it is possible to configure CPU count in two ways. CPU caging. Simplified, if you have a server with 10 CPUs, then each database gets 5 CPU each. So the database can't use more than 5 CPUs and there are no CPU conflicts. The problem with this setup is that it is similar as to provide each instance with its own virtual machine. There will be lots of unused capacity when the database has less activity. The second way is to do an over-provisioning. Same server with 10 CPUs, but instead of 2 databases, we have 3 databases, and each of them have a CPU count set to 5. So in reality, there are only guaranteed 3.3 CPUs. This will work if they have peaks at different times. The Impact Advisor will help you to identify when databases in the cluster are impacted or exposed by noisy neighbors. Databases are impacted when it requests more than its guaranteed limit, and other databases also request its guaranteed limit or more. Then it fails to get its resources. A database is exposed when it's requested more than its guaranteed limit, but other databases are requesting less than its guaranteed limit. The reason to be exposed is that if other databases request more resources, then it becomes impacted. The goal is to eliminate or reduce the impacted hours as much as possible. Impact Advisor provides a summary of impacted and exposed databases. It provides per instance level statistic over the time for 30 days. By drilling down to instance level, it is possible to get information on how much CPUs the selected instances use, how much CPUs the databases use, either as a sum or of all or for individual databases. There is also information on non-database related CPU consumption. Impact Advisor will also leverage AHF Balance Report for in-depth analysis and problem resolution. The balancing report will provide recommendations for how to set up CPU count on databases within the cluster to minimize exposed and impacted hours. Let's see how this works. We are connected to Enterprise Manager. We select Exadata. This environment has 3 Exadata machines, and to be able to access this feature, Management Pack access needs to be enabled. Let's select the third machine. On the Database Machine menu, select Database Impact Advisor. There is one cluster with 4 databases. The overall status is failed. One database is shown as exposed, and it is seen as a warning. There are 2 databases not passing the guaranteed limit. They are shown as info, and then we have one database that is impacted, and it's shown as failed. Let's look at this in more details. Expand the cluster and we can see impacted and exposed databases. Let's start and drill down on our exposed database. It has CPU count set to 4 CPUs per instance, and the cluster has 32 cores per server. The total time it's exposed is 1 hour during the month. We can also see that there were no database-related incidents occurring during the time. Let's look at the impacted database to see what's going on. This database has CPU count set to 32 on both instances. It is exposed for 1 hour and impacted for 250 hours, so almost a third of the time. There are no incidents during the time. Let's look at our databases with info only. Both has CPU count set to 32 and none of them have exposed or impacted hours. What we can suspect here is that CPU count is only configured on CB1. Let's focus on our impacted database, DBSOE. We can now see more details on the load. Between November 7th and November 16th, it was consuming almost 20 CPUs. On the 16th, there was a significant drop in the workload. For further in-depth database analysis, it's possible to click on the database name and it will send you to the database homepage. But let's continue here in Database Impact Advisor. The guaranteed limits for the database is 10.2 CPUs. So during the peak, it was using almost 2 times its guaranteed limit. Let's select instance DBSOE1. Now we get better pictures of the CPU usage. Before November 16th, we had almost 100% CPU utilization. DBSOE1 used 20 CPUs. All other instances used around 6 CPUs. In total, this is 26 CPUs. The limit for healthy usage is 70% of 32, and this is why the Impact Advisor flagged it as failed. Our database instances with info only have 32 cores as CPU count and will therefore have a guaranteed limit of 10 each. Since they don't use its guaranteed limit, they pass, but due to the total CPU usage is above 70%, they are flagged for info. The green section in the graph identifies non-database CPU. So there are other activities on this server as well. And it is almost constant even when the database activity decreases. By selecting the Show All Instance Usage Stacked, it provides a detailed graph where the usage for each individual instance is shown. With this option, it is easy to see which database that is causing most noise on the server. It is possible to annotate incidents on the graph by selecting the Show Incidents checkbox. We can also check the Highlight Impact Hours checkbox, and it will provide better visibility on impacted hours. To get a better understanding on allocated CPUs for instances, then we can switch to the CPU Allocation tab. Here it's possible to see how much CPU each instance has allocated and the number of available CPUs. This provides you with how much each server has been over-provisioned. As an example, there may be a policy that a production server should never be over-provisioned to more than 2 times the number of CPUs, while a test server or a dev server may have 4 times the number of available CPUs. The last tab in the Impact Advisor shows the incidents that have occurred for the cluster during the 30-day time window. Let's get back to the CPU Impact tab. It is an advisor, so let's see if we can get some advices on how to set CPU count for our databases. In the action column for the cluster, we select Generate AHF Balance Report. We confirm that we want to submit the report. The time to generate the report depends on how many databases there are on the cluster. When there is a green icon in the action column, then the report is ready. We can now open the report. The report provides us with in-depth information on how to set up CPU count to minimize exposed and impacted hours. The first section tells us how many exposed and impacted hours there will be if we implement the suggested CPU count, and how much over-provisioning that is needed. The timeline shows when in time we can expect impacted or exposed hours. Further down we can see this information per server. Then we have the action plan. In this section we can see that there is a CPU count reduction for every database. The DB-SOE, which was the most utilized database, should be reduced from 32 CPUs to 21 CPUs, while RAT and sales should be reduced from 32 to 5 CPUs. At the bottom of the report, we have the detailed timeline for each individual database. We can now save this report to share or to archive. This ends the demo for Database Impact Advisor.